Hello students, my name is Arshan and today we will do the 13th chapter of your science textbook of NCERT and the name of the chapter is Motion and Time Part 1. So students, in class 6th, you have learned about different types of motions. You learned that a motion could be along a straight line, it could be circular or periodic. Now try to recall these three types of motion. So in this table 13.1, it gives us some common examples of motion. Identify the type of motion in each case and allow me to solve a few. The examples of motion, the first one is soldiers in a march past. So students, it is periodic motion. Then bullock cart moving on a straight road. Students, this is straight line motion. I'm sure you can do the rest of them. Let us move forward with our chapter now. So students, it is common experience that the motion of some objects is slow while that of some others is fast. So with this we will start our first topic of this chapter, that is slow or fast. Now we know that some vehicles move faster than others. Even the same vehicle may move faster or slower at different times. You can make a list of 10 objects moving along a straight path. Group the motion of these objects as slow and fast. Now students, think that how will you decide which object is moving slow and which one is moving fast? For example, if vehicles are moving on a road in the same direction, we can easily tell which one of them is moving faster than the other. Now let us look at the motion of vehicles moving on a road and perform this activity, that is activity 13.1. Looking at figure 13.1, it shows the position of some vehicles moving on a road in the same direction at some instant of time. Now look at another figure 13.2, it shows the position of the same vehicles after some time. From your observation of the two figures, answer the following questions. Which vehicle is moving the fastest of all and which one of them is moving the slowest of all? So students, we can say that the green car is moving the fastest of them all. Now it's on to you to find out the slowest vehicle. Take the help of your parents or your teacher as well. By the way, moving forward, the distance moved by objects in a given interval of time can help us to decide which one is faster or slower. For example, imagine that you have gone to see off your friend at the bus stand. And suppose you start pedaling your bicycle at the same time as the bus begins to move. So the distance covered by you after 5 minutes would be much smaller than that covered by the bus. So would you say that the bus is moving faster than the bicycle? Certainly yes. Now we often say that the faster vehicle has a higher speed. So in a 100-meter race, it is easy to decide whose speed is the highest. So one who takes shortest time to cover the distance of 100 meters has the highest speed. So while we are talking of the speed, let us move forward onto the topic of speed. So students, you are probably familiar with the word speed. In the examples which we have talked earlier, a higher speed seems to indicate that a given distance has been covered in a shorter time or a larger distance covered in a given time. The most convenient way to find out which of the two or more objects is moving faster is to compare the distances moved by them in a unit time. Thus, if we know the distance covered by two buses in 1 hour, we can tell which one is faster. So, we call the distance covered by an object in a unit time as the speed of the object. And when we say that a car is moving with a speed of 50 kilometers per hour, it implies that it will cover a distance of 50 kilometers in 1 hour. However, a car seldom moves with a constant speed for 1 hour. In fact, it starts moving slowly and then picks up speed. So when we say that the car has a speed of 50 kilometers per hour, we usually consider only the total distance covered by it in 1 hour. So we do not bother whether the car has been moving with a constant speed or not during that hour. The speed calculated here is actually the average speed of the car, students. So in this chapter, we shall use the term speed for average speed. So for us, the speed is the total distance covered divided by the total time taken. Thus, we get the formula of speed, that is, speed is equals to total distance divided by the total time taken to cover that distance. Now students, in everyday life, we seldom find objects moving with a constant speed over long distances or for long duration of time. If the speed of an object moving along a straight line keeps changing, its motion is said to be non-uniform. On the other hand, an object moving along a straight line with a constant speed is said to be in uniform motion. In this case, the average speed is the same as the actual speed because the motion is uniform. So students, we can determine the speed of a given object once we can measure the time taken by it to cover a certain distance. Now remember, in class 6 you learned how to measure distances, but how do we measure time? Let us find that out with the new topic, that is measurement of time. So students, if you did not have a clock, how would you decide what time of the day it is? Have you ever wondered how our elders could tell the approximate time of the day by just looking at the shadows? How do we measure time or interval of a month, a year? So to answer all these questions, our ancestors noticed that many events in nature repeat themselves after definite intervals of time. For example, they found that the sun rises every day in the morning and the time between one sunrise and the next was called a day. Similarly, a month was measured from one new moon to the next, and a year was fixed as the time taken by the earth to complete one revolution of the sun. Often we need to measure intervals of time which are much shorter than a day. So clocks or watches are perhaps the most common time measuring devices. But then students, comes along another question, that how clocks and watches measure time. So students, the working of clocks is rather complex, but all of them make use of some periodic motion. One of the most well-known periodic motions is that of a simple pendulum. A simple pendulum consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. Now as you can see in this figure also, the metallic ball is called the bob of the pendulum. The figure shows the pendulum at rest in its mean position. So when the bob of the pendulum is released after taking it slightly to one side, it begins to move to and fro. The to and fro motion of a simple pendulum is an example of a periodic or an oscillatory motion. The pendulum is said to have completed one oscillation when its bob, starting from its mean position, moves to A, then to B, then back to O. So a pendulum also completes one oscillation when its bob moves from one extreme position A to the other extreme position B and comes back to A. The time taken by the pendulum to complete one oscillation is called its time period. Let us perform this activity to enhance our learning, that is activity 13.2. Activity 13.2. Set up a simple pendulum as shown in the figure with a thread or string of length nearly 1 meter. Switch off any fans nearby. Let the bob of the pendulum come to rest at its mean position. Mark the position of the bob on the floor below it or on the wall behind it. To measure the time period of the pendulum, we will need a stopwatch. However, if a stopwatch is not available, a table clock or a wristwatch can be used. To set the pendulum in motion, gently hold the bob and move it slightly to one side. Make sure that the string attached to the bob is tight while you displace it. Now release the bob from its displaced position. Remember that the bob is not to be pushed when it is released. Note the time on the clock when the bob is at its mean position. Instead of the mean position, you may note the time when the bob is at one of its extreme position. Measure the time that pendulum takes to complete 20 oscillations and then record your observation in table 13.2. The first observation shown is just a sample. Your observation could be different from this. Repeat this activity a few times and record your observations. By dividing the time taken for 20 oscillations by 20, get the time taken for one oscillation or the time period of the pendulum. Now students, after completing this activity, try and note that is the time period of the pendulum nearly the same in all cases. Also note that a slight change in the initial displacement does not affect the time period of the pendulum. So, in table 13.2, the first observation is as follows. The time taken for 20 oscillations is 42 seconds. Hence, the time period will be 42 divided by 20, that is 2.1 second. So, similarly students, you have to take several readings and then note down the time period of your pendulum. Nowadays, most clocks or watches have an electric circuit with one or more cells. These clocks are called quartz clocks. The time measured by quartz clocks is much more accurate than that by the clocks available earlier. So, while we are talking of the measurement of time, let us move on to our next topic, that is units of time and speed. So, students, the basic unit of time is a second. Its symbol is S. Larger units of time are minutes and hours. Now you already know how these units are related to one another. Have you ever thought that what would be the basic unit of speed? So students, to answer that question, since the speed is distance divided by time, the basic unit of speed is meter divided by second. Of course, it could also be expressed in another units as well, such as meter per minute or kilometer per hour. But you must remember that the symbols of all units are written in singular. For example, we write 50 km for 50 km, not 50 kms for 50 kilometers, or 8 cm for 8 centimeter, not 8 cms. So students, by all these concepts, we can find out that how many seconds are there in a day or how many hours are there in a year. So for example, let us talk about seconds. We know that there are 60 seconds in a minute and there are 60 minutes in an hour and there are 24 hours in a day. Hence, we can multiply it and find out the numbers of seconds in a day, that is 24 multiplied by 60 multiplied by 60, which will give us 86,400 seconds in a day. Similarly, we can find out the number of hours in a year, as we know that in a day there are 24 hours and there are 365 and 1/4 days in a year. So if we multiply 24 by 365.25, we get the number of hours in a year, that is 8,766 hours in a year. Now allow me to tell you an interesting story about the discovery that the time period of a given pendulum is constant. So students, you might have heard the name of famous scientist Galileo Galilei. It is said that once Galileo was sitting in a church. He noticed that a lamp suspended from the ceiling with a chain was moving slowly from one side to the other. He was surprised to find that his pulse beat the same number of times during the interval in which the lamp completed one oscillation. So Galileo experimented with various pendulums to verify his observation. He found that a pendulum of a given length takes always the same time to complete one oscillation, and this observation led to the development of pendulum clocks, winding clocks. Also, the wristwatches were the refinements of the pendulum clocks. So students, different units of time are used depending on the need. For example, it is convenient to express your age in years rather than in days or hours. Similarly, it will not be wise to express in years the time taken by you to cover the distance between your home and your school. Now, how small or large is a time interval of 1 second? The time taken in saying aloud 2001 is nearby 1 second. Verify it by counting aloud from 2001 to 2010. The pulse of a normal healthy adult at rest beats about 72 times in a minute, and that is about 12 times in 10 seconds. Now this rate may be slightly higher for children. So many times measuring devices were used in different parts of the world before the pendulum clocks became popular. Sundials, water clocks and sand clocks are some examples of such devices. Different designs of these devices were developed in different parts of the world, as you can see in these pictures as well. So with this students, we are at the end of our chapter. In this chapter, we have learned a lot of things. We got to learn that the distance moved by an object in a unit time is called its speed. Also, we learned that speed of objects helps us to decide which one is moving faster than the other. Also, we got to know that the speed of an object is the distance travelled divided by the time taken to cover that distance. and its basic unit is meter per second. Also, periodic events are used for measurement of time, and periodic motion of pendulum has been used to make clocks and watches. So students, now it's time for the exercise part. So the first question is, classify the following as motion along a straight line, circular or oscillatory motion. The first one is motion of your hands while running. So students, that is oscillatory motion. Second one, motion of a horse pulling a cart on a straight road. Students, this is linear motion. Third one, motion of a child in a merry-go-round. So students, this is circular motion. Fourth one, motion of a child on a seesaw. Well students, this one is oscillatory motion. The fifth one, motion of the hammer of an electric bell. This is also an oscillatory motion. And the sixth one, motion of a train on a straight bridge. So students, this is linear motion. Moving on to the second question, that is, which of the following are not correct? The first one is the basic unit of time is second. So we have learned in this chapter, students, that this is correct. The second statement is every object moves with a constant speed. So students, this is definitely not true. This statement is false. Third one, distances between two cities are measured in kilometers. Well students, this is true as well. Now the fourth one, the time period of a given pendulum is not constant. So students, this statement is false. It is not correct. We know that the time period of a given pendulum is constant. And then the fifth one, which is the speed of a train is expressed in meter per hour. So students, we have learned this in the chapter as well, that this statement is wrong and it is expressed in kilometer per hour. Now moving on to the third question, that is, a simple pendulum takes 32 seconds to complete 20 oscillations. What is the time period of the pendulum? So students, to solve these type of questions, what do we do first? We first write the data that is given to us in the question. So we will write the data, that is 20 oscillations, and the time is 32 seconds. So by virtue of the simple formula, we know that the time taken to complete one oscillation is equals to 32 divided by 20, that is 1.6 seconds. So time period of a pendulum is a time taken by it to complete one oscillation. Hence we can say that in 1.6 seconds the pendulum completes one oscillation. Moving on to another question. The question is, the distance between two stations is 240 kilometers. A train takes 4 hours to cover this distance. Calculate the speed of the train. So students, first we will write the data given to us. That is, distance is equals to 240 kilometers. Time taken is equals to 4 hours. So we know that the formula for speed is distance covered divided by the time taken. Hence it is equals to 240 kilometers divided by 4 hours. This is equals to 60 km per hour. Hence the speed of the train is 60 km per hour. So students, with this we are at the end of this chapter. I certainly hope that you will perform all these exercises into your notebook at your home as well, and also you will try to perform these activities under the supervision of your teachers or parents. Try to apply these laws of physics of time and motion into your daily life as well. So we will meet some next time with some other interesting chapter. Till then, bye bye.